Okay, 225, the discriminant. So we're gonna get started with some review of our very first 2.0 target. This is 2.2.1a. So pause the video and give this a try on your own. Okay, this is a quadratic function since it has a parabola shape. The x-intercepts are where it crosses the x-axis at negative 3, 0, and 1, 0. The y-intercept would be where it crosses the y-axis, which looks to be 0, negative 3. The vertex is the point at the bottom, so negative 1, negative 4 is the point. It is a minimum value. And the line of symmetry is always this line that goes through the vertex, which in this case would be x equals negative 1. Always written as x equals for quadratics. Okay. The next piece we're going to do here is evaluate some functions. So you have 5 different problems. You're told, given a is 4, b is 8, c is negative 5, and d is 1/2, evaluate the following. Evaluate just means plug in. So like if we look at number 1, we plug in 4 for A, we plug in 8 for B, and then we just simplify. 2 times 4 times 8 is 64, plus 5 is 69. Okay. Go ahead, pause the video, and do those other 4 on your own. Okay, we're back. Plug in 4 for A, plug in negative 5 for C. 10 minus 4 is 6. 4 times negative 5 is negative 20. 6 minus 20 is negative 14. A is 4, C is negative 5, plus B is 8, D is 1/2. 4 times negative 5 is negative 20. 8 times 1/2 is 4. Negative 20 plus 4 is negative 16. Down below, negative 5 for C, 4 for A. Negative 5 squared is 25. 6 times 4 is 24. 25 plus 24 is 49. Plug in A. Plug in A again. Plug in B and plug in D. 4 squared is 16. 4 times 8 is 32. Times 1/2 is 16. So we have 16 minus 16, which is just 0. Okay. So you may be wondering, why are we plugging in values here? What are we doing? What's the point? We're going to be plugging some things in and evaluating to determine how many x-intercepts a quadratic function has. So we've been solving for x-intercepts through factoring and then setting those factors equal to 0. There are some cases where it's really, really challenging to do that, but it is beneficial to determine if there are any x-intercepts that exist so that then we can continue and do our best to find those. So to find the number of x-intercepts, we have a formula called the discriminant. And we write that formula as b squared minus 4ac. Where our a, if we have a function, a quadratic function, it'd be y equals ax squared plus bx plus c, where the a goes with x squared, the b with x, and the c just our number. And this may look a little familiar. It's a piece of the quadratic formula, and there's some key connections there. But we'll talk about that later on. So if you're using the discriminant formula, you're plugging in a, b, and c, and you get an answer that's greater than 0, that means we have 2 solutions or 2 x-intercepts. X-intercept solutions interchangeable, meaning the same thing. If you plug things in and your answer is 0, it's equal to 0, that means we have 1 solution or x-intercept. And if we plug it in and we get something less than 0, it means we have 0 solutions or x-intercepts. When you're using the discriminant, it does not tell you what your solutions are. It only tells you how many you have. So let's apply the discriminant here to see how many x-intercepts the quadratic has. So if we have 5x squared plus 8x plus 2, x squared is our a term, x is our b, our numbers are c. So we plug those in to the discriminant formula, into b squared minus 4ac. So our 8 is our b, our 5 is our a, our c is 2. 8 squared is 64. 4 times 5 times 2 is 40. 64 minus 40, well, that's 24. So when we plug in our values into the discriminant formula, we get 24. That does not mean we have 24 x-intercepts. What it means, so 24 is greater than 0. So that means we have 2 solutions or 2 x-intercepts. Okay? Let's try another. So we have that discriminant form, b squared minus 4ac. Let's plug in our b value is 5 here, because that's what's with x. Our a value here is -4, so let's plug in -4, and our c value is -3. So 5 squared is 25. We have minus 4 times -4 times -3. Well, -4 times -3, well, that's 12. 12 times 4 is 48, so we have 25 minus 48, which is -23. -23, how does that relate to 0? That is less than 0. When your answer is less than 0, you have 0 solutions, 0 x-intercepts. And that's about all there is with the discriminant formula. However, you have to be careful sometimes about the way your formula is set up. Because sometimes it may not be written in the proper order. Like, for example, what if instead of 9x squared plus 6x plus 1, let's consider if we have 9x squared plus 1 plus 6x. Your thought may be, well, a is 9, b is 1, c is c, but that's not the case. Remember the formula? ax squared plus bx plus c. So your a always has to go there with x squared, your b always has to go with x, and your c always has to be your number. So be careful about the way it's set up. So you have 4 problems here. What I'd like you to do is try all 4 of those on your own, and then that'll be it for our notes. So pause the video, give them a try. Okay, we're back. So using the discriminant form, b squared minus 4ac, our b here is 6, so we have 6 squared minus 4 times 9 times 1, because a is 9, c is 1. 6 squared is 36. 4 times 9 times 1 is also 36. 36 minus 36, well, that's 0. So if we get 0, that doesn't mean we have 0 solutions necessarily. Remember, if your answer is 0, we have 1 solution. So our solution should be 1. For number 2, b squared, so -9 squared, minus 4 times a times c. -9 squared is positive 81, minus 4 times 6 is 24. 24 times 5 is 90, so we have 81 minus 90, which is negative. 9, is that? Yeah, which is -9. Wait a minute. Yeah, what am I doing? That's 120. It's not 90. 81 minus 120 is -39. Sorry, I'm doing mental math and just tripping up. Regardless, negative number, less than 0, so we have 0 solutions. Okay, here, b squared, so -5 squared minus 4 times a times c. A is 1, c is 3. -5 squared is a positive 25. -4 times 1 times 3 is -12, and that equals 13, which is greater than 0, so we have 2 solutions. Last one, 2 squared minus 4 times a times c. So b squared is 2. b is 2. So 2 squared is 4. Minus 4 times -4 times 7 is -28. -4 times 28, well, that would be 112, I believe. Is that right? 4 times, yeah, 112, so 116, which is greater than 0, so we get 2 solutions. And that's it.